Alright, now so in this video we'll be talking about the second method on getting the roots of polynomials or roots of equation. Okay, so let's start first with the theory. Okay, so the second method is an alternative to the Newton-Raphson method, that is used by replacing the derivative f prime of x with its finite difference approximation. And therefore, it does not require the use of derivatives, the f prime of x. It is commonly used, if our f prime of x is difficult to obtain or it is not explicitly defined. Okay, so going back to the Newton-Raphson method. So we have the formula for the Newton-Raphson method. Okay, that will be x, I plus 1, or I is the any subscript, or any placement of our, then we have xi minus f x I over f prime of xi. Now, if you are going to go back, to the finite difference approximation of a derivative, so we could say that f prime of xi is just equal to f xi minus f xi minus fxi minus 1 over a step lower from xi over xi minus xi minus 1. Okay, so if you are going to substitute this to this equation, so we could have our xi plus 1 equal to xi minus, so we have here f xi over f xi minus, okay, so the value of this one, so we have f xi minus 1 over xi minus 1. So using the reciprocal rule, so we could have xi plus 1 is equal to xi, that is minus, okay, so minus, f xi, then this will be multiplied by xi minus 1 all over f of xi minus f of xi minus 1. Okay, so if you're going to say, so let's let our xi is equal to, well, not I, xi, but let our I is equal to 1. So our I minus 1 will be equal to 0, so that's a step lower. Then we will also have our I plus 1 is the position of our root. So therefore, we could have this formula here, as xi, not xi, but xr is equal to x1 minus f of x1 times 1 minus x of 0 over f x1 minus f of x0. And this is now the formula for our second method. Okay, so from the formula itself, we are going to know that in order for this formula to be used, is that we must have two initial guesses, two initial guesses, and those guesses will be designated as x0 and x1. From this, we will be solving our f of x0 and f of x1. Then we're going to substitute that one to the formula. We will be getting the xr, and we will be trying to get the absolute, the EA, or the absolute error until we get to the absolute error of a certain acceptable percentage, maybe 0.05% or 0.01%, depending on the acceptable error for that certain type of computation. Okay. So to apply this concept, we will have some forms, of course, no? Okay, so we have here, if f of x is equals to sine 5x plus cosine 2x with an initial guesses of x of 0 to 0.5 and x of 1 is equal to 0.4, find the root with the stamping criterion of a is equal to 0.005, no, 0.005 or 0.05%, no, 0.05%. Okay, so let's just have the solution here. Okay, solution. First, let's list down the given. So our f of x is equal to sine 5x plus cosine 2x. So our x of 0 is equals to 0.5. Our x of 1 is equals to 0.4. Then our absolute error is equal to accepted absolute error, or the stopping criterion is 0.005. Okay, or that is equals to 0.05%. Okay, so next we are going to find, no, our f of 0, which is also equal to f of 0.5. So this will be equal to sine. So we have 5 times 0.5 plus cosine 2 times 0.5. Okay, so using our calculator. Okay, so we have here, so we put our calculator in radians. Okay, so we have sine 5 times zero point 0.5 plus cosine 2 times zero point 0.5. Okay, so we will be getting 6 decimal places for this one to ensure accuracy. This will be equal to 1.138774. Okay, so 1.138774. Okay, then we have our next will be the f of x1. This will be f of 0.4. So just substitute that one here. So sine 5, 0.4 plus cosine 2, 0.4. Okay, so this will be equal to, so we store this one in A, so because it will be useful later on. Okay, so just edit this one as 0.4, this one also as 0.4, and equal, so that is 1.606004. Okay, so we have 1.6006. Okay, that is 004. So this will be 06004. Okay, we just save this one, no? Store as B. Okay, so we have, so let's just use the formula, no, to get our root, no? So this will be our first iteration. Okay, so iteration 1, no? So we have our xr is equals to x1 minus f of x1 x1 minus x0 over f of x1 minus f of x0. So we have, so our x1 is equal to 0.4 from the given. Okay. Then we have minus f of x1 is f of x 0.4, so that will be equal to 1.606004. Then you have 0.4, f of x of 0 is 0.5 all over. So we have 1.606004 minus 1.138774. Okay, so that will be our f of x0. Okay, so getting now our first iteration of our root. So we have 0.4 minus, so I've stored its value is 0.6004 at b. So just use b times zero point 0.4 minus zero point 0.5. Then we have also recall b, no? Minus this one I've stored here in a. Okay, so to check, so b is 1.006 and a is 1.138774. So we will have 0.740. So 3 decimal 729. Also 3 decimal places. So 0.743729. Okay, 29. So I just restore this one also. So C. Okay. Then also I will try to get the f of xr, which is equivalent to f of 0.743729. So we substitute to the given equation. We have sine 5x, so 7.74729 plus cosine 2 times 0.743729. Okay. Okay, so now just solve for this one. So sine 5, so that is stored in c plus cosine 2, so this is restored in c also. So that will be equal to negative 0.462, 4 point, 0.462314. Okay, so this is store that one in D. Okay, so this is equal to negative 0.4, so 2314. So 62314. Okay, so we're going to get the absolute error. So this will be equal to xr minus our x1 over our xr. So that is the absolute value times 100%. So we have 0.743729 minus our x1 is 0.4 over 0.743729. Okay, so times 100. So using our calculator, we have, this will be recall C minus 0.4, then recall C. Okay, so times 100 is equal to 46.22. Okay, so 46.22%. So still far, no, from our goal, no, or for our stopping criterion of 0.05%. So we proceed to iteration 2, no. So iteration number 2 Okay, for this one, our x0 is now this 0.4, and our x1 is the xr, which is 0.743729. Okay, so solving now for our new xr. So you have x1 minus f of x1 times x1 minus x of 0 over x1 minus f of x1 minus f of x0. So substituting, so we have 0.743729 minus, so f of x1 is the f of xr here, no? No, okay, so that is negative 0.62314. So we have negative 0.462314. I multiply this one by 0.743729 minus 0.4 all over negative 0.462314 minus, so our f of s0, 0.4, so that is equal to this one. So 1.606 is equal to 1.6006004. Okay, so solving now for our new xr. So we just have to do this one here. So we need to recall C, no? So our x1 is stored on C, no? So minus, so this value is stored on D. So alpha D times alpha C minus zero point 0.4 all over, so D minus, so the value of f of 0.4 is stored in B, that is 1.6060004. Okay, so to check, okay, so 0.743, then we have negative 4.462314. Okay, so B is also correct. So our value now is equals to 0.668 898. Okay, so we store this one on A. Okay, so we have 0.66898. So solving now for our f of xr, which is equal to f of 0.666898. So this is equal to sine 0.666898 plus cosine 2 times 0.66898. Okay, so we'll have, so using our calculator, so we have sine 5a plus cosine 5a. 5, not 5, but 2. Okay, so uh, so the answer is 0.043. Okay, so just store this one on B. So 0.043, 083, 084 pala. Okay, so 0.043084. Okay, 084. Okay, so let's just test now if our absolute error is now on the top It's now less than the topic criterion. So you have xr minus x1 over xr. So we have 0.666898 minus 0. Our x1 is 7.43729 all over 0.7433729. So times 100. Okay. We have recall A. Okay, so I believe I made a mistake here. No? So this is 0.66898. So 0.66898. Okay. Okay. Now let's have this one. So recall A minus C over A. Okay. Okay. So times 100. So we have 11.52. So negative, but our formula is an absolute value. So we could still write that one now without the sign. So that is 11.52%. Okay. So still not equal or less than to 0.05%. So let's proceed with iteration 3. So for this one, our x 0 is equal to 0.743,729, and our x1 is just equal to 0.6666898. Okay, so let's solve now for our new xr. So xr is equal to x1 minus f of x1 times x1 minus x of 0 over f of x1 minus f x0. So we have 0.6666898 minus f of x1. So we have solved that one earlier. That is f of xr. Okay, so that is 0.043084. No? Okay, so we have 0.043084. So 0.84 multiplied by 0.66898 minus 0.743729 all over. So 0, that is 0.043084. So I think this is negative. Let's check. Is it negative? Okay, just check. So f of x0 or f of 743. So this is equal to, this is the negative. So negative, so 462314. So negative 462314. Okay. So let's just check here. So we have stored already our values. Now let's try now to calculate the new value for xr. Okay. So we have 6698. So this will be alpha A minus our value now for this one, which is this could be B. Then we have alpha A, then oops, so minus our 0.743,729. It should be equal to recall B minus recall B. So calc Okay, so B. So we have this one. Let's store this one at C. So we have 0.6734 48. No. So we have our new XR is 0. Okay. So 673,673,448. So solving now for our new XR. So this is equals to sine 5, 0.673448 plus cosine 2 times 0.673448. Okay, so we have here sine 5c plus cosine 2c. This is equal to, that is negative. No. Okay, so we have negative 1.70 1281 okay, 1282 times 10 to the power of negative 3. Okay, solving for our absolute error. Okay, times 100. So this is equal to 0.673448 minus 0.666898 over 0.673448 times 100. Okay, so this will be equal to, so we have, okay, so we have recall with B minus A over C. Okay, so times 100. Okay, so we have 0.97. So that is 0.97%. Okay, now we proceed to our iteration 4. So we are still on the stepping criteria. So iteration 4. So our x of 0 now is equal to, x of 0 is equal to the 0.66898. And our x1 is equals to 0.6734448. So solving for xr, so we have x1 minus f of x1 times x1 minus x of 0 over f of x1 minus f of x0. Okay, so substituting the values, we have 0.67348 minus f of x1, so which we have solved earlier, so that is the negative. So we have negative 1.701282 times 10 to the power of negative 3. Then we have x of 1, which is 0.6734448 minus x of 0, which is 0.66898 all over This will be negative 1.71284 times 10 to the power of negative 3 minus our f of x0 or f is 66898. So that is equal to 0.04388084. So 0.043084. Okay. So our new XR will be, okay, so we have, so this will be C, we call C, okay, so C minus, so f of x1, so that will be D, then we call C minus our A, which is the 0.66898, then we have recall D, no? Minus recall B, okay, C is correct, D, then B, okay, let's see our B, okay, so we have, so 0.673199, okay, so 0.673199, okay, so let's try now first, no, before we go to the f of xr, let's just have first the absolute value, okay, so we have xr minus x1 over xr, so this is equivalent to 0.673199 minus 1, which is 0.673448 all over 0.6739199. So times 100. Okay. So if it equal or less than to 0.05%, then we will stop our calculations. Okay, so just store in E. So recall E minus recall, this will be C over recall A. So okay, so we have, so that will be times 100. So we have 0.037 negative at the absolute value. So we have 0.037%. Okay, so our value now, or the approximate root, because we are now less than 0.05%, so our approximate root is equals to 0.673199. So this will be now our answer. Okay, so I hope you understand something in this video, and as always, enjoy learning.